In this next module, we'll introduce Model View Controller, or MVC, to our project. We're going to add MVC support to our ASP.NET Core project. We're going to create some controllers. We're going to then create some views and layouts, introduce model validation, and then show you how to use tag helpers. Let's get started. So in ASP.NET Core, MVC6 is the Model View Controller framework for our application. And when I talk about Model View Controller, it's really three separate pieces that are going to work in conjunction. The model represents the data you're going to deal with, the controller represents the logic, and the view is the markup that you're going to display to users. So when a request comes in, it's going to be routed to a controller class. That controller class is going to optionally get some data through the model or be passed data from the request as the model. And that model may interact with a database somewhere. And then that data gets sent back to the controller to do any logic that needs done. And then the controller is going to send that data down to the view. And the view is going to render that and return that as the response to the user. Let's see what this looks like in code. So let's create our first controller and view and see how they're related. Back in Visual Studio, I'm simply going to create a new controller class. And the convention is that a controller class is going to be inside a directory or a subdirectory of a directory called controller. So let's make a controllers directory first. And so here we can create our own controllers. I'm going to start with just something I'm going to call the app controller. And this is just a C# file. This class is going to derive from a class inside of MVC called controller. And it shows the red squiggle. And that's because we need to add the using statement for Microsoft ASP.NET Core MVC. The default key for popping up this sort of helper to help us solve the problem is Control period, or you could, of course, hover the mouse. Now that we have a controller, let's create what's called an action. Now, a controller allows us to map a request that comes in to a specific action, and that action is where the actual logic is going to happen. So I'm going to create a new method that returns an interface called action result. Action result knows about ways of taking what happens here, mapping it to a view, and returning it ultimately. And I'm just going to call this index with no parameters. And because I want this to actually return a view, I'm actually going to call view as the thing that it returns. And so the logic in here could do a bunch of things. It could return an error, it could redirect it to a different place, or it could return it to a view. So what view is it actually going to look for? And in ASP.NET MVC, there's a convention. The convention is to use a folder called views, which we'll create first. And then within views, it will gather up all the views, or it will look in folders for the views based on the name of the controller. So the name of our controller is app. Even though it has the word controller on it, it's conventionally going to assume that the name of the controller is just app and that the word controller is just descriptive. So I'm going to create another directory called app, and this will contain all the views for my app controller. And the name of the actual view is going to be the name of this method, which is the action. And what this view represents isn't HTML itself, but what's called razor. Razor is a syntax for generating and for doing replacements and adding a small amount of view logic in the code itself using C#. So if we go to the app folder and we create a new file, again, it's going to have the same name as our action, so index and index, and the extension is CS.html or C#HTML. If you're using Visual Basic or using F#, the name of this would be different based on that language, VB.html or FS.html. The views themselves use this razor syntax, and that syntax always starts with an @ sign. So if I wanted to have a small code block, I would just have an @ sign and then a begin and end paren. And you'll notice it's colored yellow here because that way you're being told by the editor that it knows that this is Razor code. This isn't markup like HTML. This is actually the Razor code. So let's use a class that we'll talk about a little later called ViewBag. And I'm just going to say that the title of our page is going to be Homepage. Now we need what our actual page looks like. So let's go to our www root. And let's go ahead and grab the contents of our HTML file and use this as the starting point. I'm just going to copy it and paste it in this whole directory, that same file that we've been dealing with. So the way we might want to use Razor is to take this ViewBag title, which is this bag of properties, and use this title in different places in our project. So let's start with the title of the page. Let's say Dutch treat at viewbag.title. And what Razor is doing here is it's saying, oh, the @ means this is going to be some C# that's referenced on the page, and then I can just use the name of the application. I don't need to actually surround it with curly braces because I'm not running arbitrary code. I'm taking some variables I have and sticking them in the page here. We take the same thing and put it here instead of Dutch treat. When we run this page, the C# that's embedded in here will be executed and will do those replacements for us. Later on, we'll see how this is executed even more by being able to do like take data that's been passed to us by the controller or to take other variables that are passed by the controller and use them here. But we'll take this one step at a time. The other thing, because this is a CSHTML page we want to deal with, we're going to want to change the different links we have. So there's not a whole lot of them on the page yet, but inside Razor, it wants to use a beginning which says ~/. And what that ~/ does is it says this should be at the root of whatever website I'm deployed in. And so this is similar to saying just the root of the project. But it's saying no matter how this is hosted, I'm going to attempt to do the right thing. So let's copy it here at our CSS. Let's copy it here at our image. We also need to do it on the jQuery and here on index.js. This is just going to guarantee that all these come from the logical root of the website. For index and CSS and image, that's all going to be www root. And for the node modules directory, it'll be, of course, the node modules directory. Let's go ahead and run this. And here we can see that it looks like the same page we were running before. In fact, we know it is because this Dutch treat should say homepage, and this title here should say Dutch treat : homepage. So what's happening? What's happening here is we haven't actually turned on MVC. We've created the controller and the view to support MVC, but we haven't actually told ASP.NET Core how to enable MVC and how we want to work with it. Let's do that next. So now let's enable MVC in our startup. As we saw before, we're still getting this index.html serving instead of our controller or view. And that's because in the startup, all we have serving is this default files and static files. What's important to note here is that because this is the chain of every request, we don't have anything that's serving our MVC or controller and views. So to do this, we first need to get rid of the default files. We're not going to let index.html be served anymore. Instead, we're going to continue to serve static files. We want to do that early so that our JavaScript and image files are all going to be served automatically, but we want to introduce something called routing. Routing allows us to route individual calls that come into the server to specific pieces of code. And we're going to do that with something called endpoints. Endpoints allows you to specify a set of middleware that's going to be handled in order to try to satisfy requests to the server. And we're going to do this by introducing a lambda. And in this lambda, we're going to say map controller route. This is going to allow us to build up a pattern. And so I'm going to call this our default route. I'm going to do this on a couple of lines so it's a little clearer. And then I'm going to use a string to specify what I'm looking for. So if I wanted to map something like /app index, I could create a route for that and then tell it where to go. So I could tell it to go to the app controller, controller equals the app controller that we want, etc. But we're not going to do that. We're actually going to tell it that we want to use a pattern matching. And so we're going to say that the first element of the URL is going to be that controller, and then we're going to want the next one to be our action. Remember, we created an action on the controller called index. And then the last element, if supplied, is going to be an ID. We tell it that it's optional by putting a question mark after it. Just like you would think a question mark after a data type in C# makes it optional as well, or makes it nullable if you want to think about it in that way. And then in this anonymous object, we're going to tell it what the defaults are. And why would we do that, right? Why would we say we want the controller to be app by default or action by default? The reason is, so we're giving it defaults if they're not specified. So in our case, when someone goes to the root of our page with the controller, the action, and the ID not specified, we're telling it that we want you to go to the index of the app controller by default. That's how we're specifying that it's that root action. This also means that once we have more controllers, if someone specifies a controller name here, just the controller name, we're going to be able to default to the index as the first page or response for that particular controller. And if we run this now that we have our defaults set up here, you notice it still has a problem. And what is the problem? It says that unable to find the required services. And you can even see that it's saying add controllers here, because what we've specified is that we've mapped it to this controller that we're looking for, but none of the required services for that are there. And so let's go back to startup. And this configure services is specifically for that, for us to configure what services the server needs so that when this gets called later, it can ask for services that it requires. And so we can do this by just saying add controllers, and we're going to say with views. There's two versions of this, an add controllers without views, and that's typically for API scenarios only. In our case, we need controllers and we need views because we're going to be returning web pages as well. And so we go ahead and run this again. Well, we will see that we're actually showing that view now. And we know that because we put Dutch treat site in here and in the title of the web page. So we're no longer getting that index.html. We could still have that index.html here because it's still in the www root. And for the most part, we don't really want that, right? We see the just Dutch treat and Dutch treat site. So we know they're two different versions. Back in our project, let's go ahead and actually just delete the index.html now that we're not going to need it anymore. So someone doesn't go to that page accidentally or have that viewed later. So now we have our controllers being executed and we have our views being executed as well. One more piece of information as you're building your application that's going to be important, and that is how errors are shown. Now, what is an error? You'll notice if we go to like foo.bar here, it's not going to show us an error at all because this isn't even considered an error. This is actually considered, if we refresh the page, let's go over to network, that foo bar is not found. It's a 404. And so we'll show you a little later how to map those kinds of errors, those status code errors separately. But let's talk about, what you may be used to in other systems and ASP.NET and others of actually showing error information. Let's throw a new invalid program exception. Bad things happen to good developers, right? Something bad happened either in your index or more likely some other component that you're using, and something bad happens. Let's go ahead and run this and see what happens. You still get no error. And if we look at that, we can actually see that what's happening here is that it's getting a 500 error. It's saying a server error, which is in reality the correct thing, right? A 500 error is that the server had some unhandled error that it didn't know what to do with. And ordinarily you would want to handle these errors and show a friendly page, sorry this happened, etc. But before that, and in development, we want to be able to show an error page so developers can go, oh, what the heck happened here? And we go back to our startup, we can actually add it first. app.use developer exception page. And I absolutely love this name for the API because it's a page that handles exceptions, not status code errors, but exceptions, and it's for developers only. So let's add that for a minute. And if we refresh, we'll see that we're getting a pretty good page that's going to help us. It's going to show us a full stack trace, going to let us see different parts of the request. so we can see what's going on, even how the routing happened. That's all great, but we never want the end users to see this. So in the old days, what would you do? You would probably do something like if debug, else if, right? And this works only if you're only shipping release versions to production. But what happens when you want to do this for, let's say, testing or staging servers or those sorts of things? This becomes more trouble than it's worth, because this is based on whether you're building a debug or release version, not what environment you're in. And so to handle this differently, you can actually use this web host environment variable that's being passed in so helpfully and say env is development. So in development, we want to show this. But what does in development actually mean? How do we know we're in development? We know we're in development not because it goes through and tries to find who has Steam installed and has more than one game installed on their machine, or whether the terminal is active. None of those sort of ways that you would normally look at a machine and go, oh, that's clearly a developer. The way it does this is actually, if we look at the properties of the project, we look at debug, we're actually setting an environment variable called underscore environment, ASPNET core underscore environment, that says what kind of environment we're in. And for debugging and using Visual Studio, development's always going to be there. In fact, what's happening here is it's calling another method on env that says is environment. And what is it doing? It's looking for that. That is essentially the same code that is development looks like. And what this means is that you could have any number of these environments you want: staging, testing, production. In fact, production's interesting because production environment is assumed to not have an environment variable or have it set to production. So by not worrying about this, when you get into production, it'll actually become production because you haven't set that environment variable to tell Visual Studio, or to tell the runtime, more importantly, what environment you're in. So let's go back here and just say is development, because that's sort of the easy one. And you'll see that there's ones for production and staging built in with those names. But if you have other environments, instead of having these fixed, just 3 kinds of environment, you could certainly see what any of those are. You can actually see what the name of the current environment is as well, if you wanted to do some special casing or do some crazy things with it. But we're going to use it just to say in development, we're going to show this difficult page. And again, if we run it, we're going to still get that page because we're running in development because of that environment variable. Now that that's working, let's take a look at layout pages next. So next, let's create a layout view. If we look at a typical web page that you're working with, you often have a fixed set of UI that's common to every page. This is what we often call the Chrome, especially before the Chrome browser, we've called it the Chrome. And that's usually the header, maybe the way the sidebars work, maybe the footer with the copyright, has these different parts of the page that we want to be able to reuse. And this is most easily done in MVC by creating something called a layout page. Let's see what this looks like so you can see what's happening. So back in Visual Studio, let's create a new directory called shared. And this is going to contain anything in the views that is common across different controllers. And a layout page, or a master page as some people call them, is a common thing that is going to be shared across different controllers. And I'm going to create a file called underscore layout.cshtml. It's just another razor view, just like the index.cshtml is. But it's a little special. I'm going to go over to the index.html and I'm going to copy everything in here temporarily. And I'm going to copy it all into the layout. The reason I'm doing this is the header of our HTML document, maybe this title here on part of the page, that's going to be common for every single page. But all this content that's specific to the index.html isn't going to be there. In fact, let's create a couple of elements like a header to say, welcome to Dutch Treat. Let's create a footer called copyright 2017 Dutch Treat LLC, which doesn't exist, but you can see kind of where I'm going with that. And then let's wrap this in something called a section. These are HTML elements that help define sort of the structure of a page. Headers and footers should be obvious, and then section is for any visual section we have on a page. The idea here is that we want to have a placeholder here for what's actually responsible in the index view or in any view for just adding their pieces so that we're not repeating all of this boilerplate on every single page. We can do that by calling render body. Effectively, render body is going to take the body of a CS HTML file and stick it in here when it's rendering it. So let's go back to our index.html and let's get rid of all the boilerplate to leave us with just the guts of what this page should be about, which is going to be about this product info, this form, that form, but not any of the script and stuff here. It's just going to be the raw code that this view actually has to deal with. And you'll notice that we can keep the title of our page here in the view, and that data is being passed into the layout and being used on each of these pages. So we now can have each page set its title and will automatically display it here in the project. So let's go show this working and see what happens. When we refresh it, we're losing a bunch of stuff, right? The header's gone, all the styling is gone. And that's because our JavaScript and our CSS is all in the layout, and our header and footer in the layout, and all of them are missing here. And the reason is that this index.cshtml doesn't know where its layout is. It's not going to use a layout by default. We could actually tell it layout equals and then give it a name, but having to do that on each and every page is not helpful. What we actually do is in the view folder, we can add a new item inside web called the MVC view start page. We can see this is underscore view start.cshtml. And this is added at the views folder so that every page can respond to it. And you can see by default what it does is it sets the layout to this named layout that we had created here and shared. This effectively sets up a base class for all the views. This is executed in each of these views as they're rendered. So because we're setting the layout to be this layout file, we can now see the header and footer. We're getting the home page injected for us, even though we had it on our main page. And us being the sandwich of the page continues to happen and continues to work. In fact, the scripts that were in the layout page continue to work. We should continue to be able to click buy or make this go away or show up. All that code is still there because essentially the request is coming in, it's looking at the index.cshtml and going, oh, okay, there's a layout. So let's take the contents, once I've rendered them, stick them in the layout, take that whole layout file, and then deliver that back to the browser. And in this way, we can make the changes to the Chrome of our application when we get to it, especially in the Bootstrap module. And we can do it in one place without having to repeat it endlessly on every page. Next, let's talk about the workflow for adding more views to your project. Back here in the app controller, you remember we created an action for index and a view to match that. Let's go ahead and create a new action result for a contact page, which we'll implement in a little bit. We'll go ahead and say return the view, but this time we'll use that viewBag.title to set the title of our page directly here in the controller. And like we did before, let's go to the app view folder and just create a contact.cshtml. The name of this razor file, the CSHTML file, needs to match the name of the actual action. That's how they find one from the other. And we'll just start with a quick H2 and we'll just use that viewBag.title and we'll leave it completely blank for now. We're going to come back and implement that in a couple minutes. Let's do the same thing again. For our third view, we'll call it about. And then just return view again in the same way, and we'll come back over to the app folder and create an about.cshtml. And we'll use this in the same way, H2, about us. And here I'll just put a little more to follow, since we're not actually going to implement the about page at any point, but it's a nice placeholder. So if we run the project, We have our page here that is our index page, but how do we know how to get to our contact and about page? If we go back to the code for a moment, and we open up Startup, which is where we had specified it, we can see that we said that the controller by default is app, and the action is index, but we can use this pattern of controller/action to get to those pages. So if you remember, our controller is called app, and our contact page, again, the name of the action is contact, and so this will actually take us to that contact page. And I'll do the same with about. But we'd like to have a list of links there that actually take us there. And let's do that next. Back in the layout page, let's add to our header here. I'm just going to surround this with an H1. And so this will be at the top of every page. And I might also want a menu. And the menu element here is useful for indicating where on the page a menu is, but it's not going to magically make the menu. It's just saying that this area of the page contains the menu. So let's just use an unordered list to build a menu real quick. We can do that with anchor tags that specify where our home page is. And because we know that it's app.contact, we can add our contact page. And because we know it's app/about, we can put that to our About page. Back in the browser, if we refresh, we'll see this is a small vertical menu for us to pick from. And now we can finally go between the pages pretty easily, depending on what we want to do, right? It's not brilliant yet, but we're getting there. I don't care for this sort of format. So let's just open up that CSS file and let's style that. The idea here is that we might have ways of styling our menu without having to even set a class or an ID. So in our case, I'm going to start it out with menu and say that I want list items to be styled a certain way. Now the LI here says it's some child of menu, so we don't have to have the entire menu list item. But if you wanted to guarantee that they were only children, you could use a greater than symbol to indicate that you wanted them to only be children. So if I really wanted this to be purely only the unordered list inside the menu and the list item that was contained in the unordered list, I could do that. But for brevity, I'm just going to say whatever list item is inside my menu, I'm going to assume is one of these guys. And let's just say display.inline. Back in the browser, this is just going to move this to be a horizontal menu. Let's make it a little better before we get into a lot of styling there. And one of the things I'd like to do is I'd like to put pipes in between them just as a decorative way to separate the menu items. And CSS has some really interesting ways of doing this. So if we do menu li again, we can say after. After is going to say, after every li item, do I want to shove some content in there? And so I'll say content, and then there's my pipe. Back in the browser, we can see we're getting that now. But of course, we're getting too many pipes. And we probably want to put a space in the beginning of the pipe as well. Let's go back, put that space in there, refresh it again, and it's looking better, but we still have that last pipe because it's putting one after each of these types. That's not really what we want. CSS even allows for this idea. Menu li, last of type, after. And so we're basically saying the last one in the list of these, let's give it an empty string to put after it instead of this after. If we did this right, we're now getting just the menu items we wanted. And if we added more, it would add the pipes in between each one and drop the last one for us. And so CSS can be used to do some of these niceties. This is really only a hint at some of what CSS can do, but I wanted you to see that. But we still have a problem. These links work, but they're fragile. Let me show you what I mean. Here in the layout.cshtml, we have these hard links. And what if we move the contact page to some other part? We change the routing in some way because we want it to be used in a different way. We want to make these not as fragile, not as search and replace required. So that when we make a change, we don't have to go search every part of our Razor files for a change like this. And we'll do that next. Let's introduce you to tag helpers, including a way to make our menus not so fragile. Now, in the last video, we talked about how fragile these links were. We'd like to have a better way where we can really say, please create a link for us that's mapped to the app controller and the contact action. But before we can do that, we're going to need to bring in what are called tag helpers. These are a way to annotate the Razor markup to change the HTML in some smart ways. So we first need a way to bring it in. To use tag helpers, we're going to need another file here at the root of the view folder. So if we go ahead and say add new item. So if we come down to ASP.NET Core and then web, one of the things we're going to find is the view imports page. If we click on that, you'll see that it's named _ view imports. And this is going to be a place that we can do a couple of things. The idea about the view imports is a way to add things that are going to appear on every page. The most common usage of this actually is to use @using statements. This will take a namespace and include them in any of the views, so you don't have to use full namespaces in any of these files. And I'll just add the controller namespace for now. What we're actually going to use it for is add tag helper. That's a type of declaration in this file to add a set of tag helpers that are used by these pages. What's interesting about this is that you can create your own tag helpers and just include them here to be used by the whole project. We're going to bring in Microsoft's tag helpers by specifying the assembly and then that we want everything in that assembly to be included as part of the tag helpers. With the tag helpers added, let's change this code to use the tag helpers to make our life a little easier. So instead of specifying an href, what we're actually going to do, and all the tag helpers start with ASP dash, and we're going to say controller equals app, and ASP action equals index. So we're specifying the controller and the action in this case, and we're asking it to specify the correct URL for us. This way, if we change the way the routing works, we don't have to go find these in every file and make sure we have them correct. So this is app and contact, and app and about. If we refresh the page, we're going to see that those same links are now working. But let's move one of those so we can see what that actually looks like. If we go back to our app controller, let's specify a route that's specific to contact. This is a common case where you want to have the default routing in startup, but you might want to have exceptions here. We can do that by giving the verb first. So I know this is going to be an HTTP GET. And inside, I can actually put a string that shows the pattern that I'm going to have this action work with. So I'm just going to say contact, right? Instead of having app/contact, I'd like contact to be a little bit more discoverable and be directly on the home of the site. If we save this change, we come back to the page, we'll see that home is still just the root of the website, about is still under app about, but contact is now just /contact. So because we've changed the routing to work there, these app controller and app action tag helpers are going to do the work for us. So in as many cases as we can, we're going to want to use these tag helpers in the Razor pages to make sure our links are not fragile. And of course, the new contact page does respond to the same one because they're linking. So when it generates these links, it's actually looking at the controllers and their metadata to figure out what the URL is for it. Next, let's introduce you to a concept called Razor Pages. Not Razor Views, but Razor Pages. Now let's introduce Razor Pages. So let's go to the startup in our project, and remember that we're using use developer exception page for development, but we also want to be able to do the same for when in production or when not in development. And we're going to use this by saying exception handler. And this is going to allow us to have a pipeline that catches the exception. It's going to log it for us automatically, but we're going to actually tell it we want to go to a specific path. We want to go to an error page for our exception. And we're just going to have this go to /error. And the trick here is that we're not going to necessarily create a brand new controller or create an action in a new controller just for this one use. We're going to introduce something called Razor Pages. Before we see this work, let's go ahead and change the environment to production. If we look at the properties for the project, when we run, we have this environment variable, ASP.NET Core _ environment, with the value of development. We talked about this a little earlier. To change this to be a non-developer, we can just change the value, say, to production for now. Production is actually okay if there is no environment variable as well. It's the exception to that. But we're going to change it to production so we can test this new facility. We'll be turning this back to development pretty soon. So if we go to our app controller, and here on the contact page, let's just throw an exception like we did earlier. And if we go ahead and run the project and go to that contact page, we're going to see nothing shows up. In fact, if we launch it, it's going to fail. And this isn't working because our error here doesn't have a listener. There's nothing matching this pattern. Remember, we made this pattern down here, and this would assume that the controller would need to be named error, and that controller itself would have an action called index on it. And of course, we don't have anything like that. Instead, we're going to use Razor Pages to do it. And we're going to come over here. Now let's create a new top-level folder called Pages, which is the conventional name for it. And then we're going to create a page called error.cshtml. And by convention, this name is going to be mapped to whatever this name is here. We're going to assume that these named pages are going to be mapped directly to the URLs. Let's create something simple here, like, sorry, we've had a problem. Please retry later. Or whatever you think an error page should really do. Let's go back to the browser now that this page exists, and when we run it, we're still not getting it. So back in Visual Studio, while we have the startup telling us to go to error, we haven't actually enabled Razor Pages to actually work. And there's two reasons why it's not working. First of all, this has to start with an at page declaration. That's what tells the system that this is a Razor page. But we also need to opt into it in startup. By default, adding controllers with views isn't enough. We also have to add services.add Razor Pages. That adds all the pieces that we need for Razor Pages, but we also need to opt into it here as well by saying map Razor Pages. And this just says, oh, I'm going to use the default page name of view declaration that we have in Razor Pages. We have to opt into both of these. In fact, while we're here, let's go ahead and add one more feature that we have, which is add runtime compilation. Now notice it's giving us a squiggly, and that's because this is actually a different assembly. So let's go ahead and manage our NuGet packages and browse for Razor compilation. What we're looking for is Razor runtime compilation. The reason we're using this is we're telling the system to recompile the Razor Pages on requests where the Razor page is changed. This is really useful for development. And the reason for this is that way, as we make changes to the actual Razor Pages, both the views here in views or in pages, that we're going to get that recompilation at runtime instead of waiting for the entire build to kick off. This allows us to more quickly make those edits and go through them. And you'll see your development time should speed up pretty much. And if we did it right, we have Razor Pages runtime compilation as well as Razor Pages added in both places. And we go back to run our page, where we see we're getting that error page finally. Now, we're not showing any of the information, but it's enough to know that in production, we're going to get a page that we can then make look better. And of course, this doesn't include any of that layout for our Razor Pages as well. So you may be wondering why this wouldn't actually work. We have our shared view here. We have our view start here that's telling us to use layout. It should just work. But currently, views and pages are entirely different worlds. So if we copy our view start, we don't want to move it, but copy it over to pages so that it also has a view start. It will use the layout in the shared directory. It just needs its own view start and view imports if you're going to end up using tag helpers. And so we now have a page that doesn't require us to craft up a thin controller. And you could certainly build a lot of your application this way. But when we start to get deeper into controllers, I think you'll see why you want to build controllers for a lot of your pages. But when you're just displaying some simple text, building Razor pages can be a way to save you some time. Let's go build that contact page next. So now let's use MVC to implement our contact view. Back in Visual Studio, we have the contact.cshtml file open. That's the one we created in the last video inside the app directory. But let's go open www.root and open up that old index.html file, because we'd already created the form for our contact page as an example. So let's grab this form. I'm just going to copy it. I'm going to paste it here into our new contact view. The only change I'm going to make is I'm going to add into the form method. The idea here is I'm telling the form when it gets submitted to use a post back to the server. Because I'm not specifying where the post should happen, it's going to be sent back to the same URL we're actually on. So if we go ahead and open up the controller for app, and you remember our contact action here, we can create another contact action. But this time we're going to accept some payload from the page. And I'll just call that my model. Let's also, while we're here, get rid of that exception that was being thrown in the last video, since that's not really helping us. And I'm just going to say return view here, just like I did in this contact call. Now, what would be different between these? How could it know which one we actually want to call? What we're going to do is use an attribute called HTTP post. This is telling MVC what kind of request is coming in when I map these. So even though these are going to have the same URL pattern, it's just going to be /contact for both of them, this is going to get called when we try to do a GET, which is a simple way of retrieving a page from the browser. But when the browser wants to send us back information, it will do that in the form of a post. And then this piece of code will be called. And I'm just going to set a breakpoint in there for a moment. Remember that this is being called post because our form itself has the method of post. That's how that's all tied together. So let's run this with debugging. And let's go to the contact page. And you can see we now have a form. Let's just put some data in it. I'm going to just put some dummy data in there. And I'm going to press send message. This is going to take us to that post method, because simply by telling the form that we wanted to post it, it sends it to us. And if we look at the model, we can see that it's instantiated itself as an object, but there's no data associated with it. The reason for that is back on the contact page, each of the inputs and text areas don't have a name associated with it. So the trick is that the name is going to be used to know how to tie what data is put in that input or text area and what to call it when it's being sent. So let's just add names to each one of these. And again, these should be the names for the kind of data. I know the first two are a little confusing because we're calling the name, but that's because that's the user's name, and calling the name email because it's just the email for the user. But you can see here we're using subject. Then on the text area, we're going to go ahead and say message. So let's press F5 to let it continue. We didn't do anything, but it did take us back to this form. Now notice that the form is shown in this page, but it's actually missing those titles. Let me show you what that's about. In the app controller for GET, we're actually setting the title here, and that's what tells the layout to go ahead and display that title. In fact, we have it displaying the title twice. So let's open up that layout for a moment. And we can see that each page is being titled directly using the ViewBag title. So on our contact page, let's go ahead and get rid of the ViewBag title, because that's a duplicate. And that back in our app controller, let's go ahead and add that ViewBag here. If we don't want this to have to be specified in each call that we might go back to the view with, the alternative, which is the one I usually do, is to not do them in either of these calls, but to actually do it at the top of the form. Now, you may ask yourself, what is the benefit there of putting it in the form if all I'm going to do is force it to put it on the page? That's because this view bag title is being sent down when the layout is called. And so that way it's implemented, or it's shown here in the layout page, but also used here in the title. So we're using it as a way to communicate down to the page. So now that we've added those names, let's run it again. Go to that contact page. Let's put in some dummy data again and see what happens this time. Now we're actually getting the data from the form now, but we don't know how we actually want to get it. The problem is that if we look in the debugger for this .request, we can actually see that there's some form data being sent. There's 5. Their keys are name, email, subject, message, and then this magic one called request verification token. And that's a little magic that ASP.NET Core is doing to make sure that this wasn't an automated way to spam your website's contact page. And then we can actually see the values here. Sean Twain, the email, the subject, the message, etc. So how do we actually get this working? What we're going to want to use is work with something called model binding. Again, the model here is the M in MVC, the model view controller trifecta, or triple if you want to call it that way. The model is the way that MVC can help you deal with the data you're going to be dealing with. And let's do that next. So now let's talk about an important concept, model binding. Back in Visual Studio, let's create a new directory called View Models. Or sometimes you see the name of the directory as just models, but I think View Models makes more sense in what we're doing. And I'm going to create a new class here to represent the data I want to deal with on that contact page. So I'm going to call it my contact view model.cs. And this is just a plain old class that has properties. So we can add properties here for name, email, subject, message. So the same 4 pieces that our form is going to use. But it's creating a convenient way to store and access them. So back in our controller, instead of accepting model, we can tell it to accept a contact view model. And what MVC will do here is it will map the names of those input and text area fields, or whatever field you use in your form, to the properties of the contact view model. And case isn't crucial at this point. So just because we use lowercase in the HTML doesn't mean we need to use lowercase in the view model. It just needs to conventionally match in a way that it knows it's the same thing. So if we set our breakpoint and run this again, with the view model intact, and I'm just going to refresh our contact page, resetting the form. Now we have a model that has automatically filled in all those 4 pieces of data that our form had. We have a way to map from the form into a class, an instance of a class that we can directly deal with in C#. This is one of the basics around model binding, is it wants to take arbitrary types that are brought in from the web and bind them directly to classes in ASP.NET Core. You're going to see the same model binding not only here in views, but later when we implement APIs, it's going to do the same thing. But we can actually make this even better, because the model binding can allow us to do things with tag helpers to make us build these forms a little easier. So let's stop this for a moment. Let's go over to our contact page. Let's add a new declaration at the top called model. And model will allow us to specify that this page's model is contact view model. Now, we aren't getting this lit up. I actually can't find it. And the reason is it wants the full namespace declaration here. But if you remember in our views, we have that view imports file here. And so we can just add a new using .treat.viewModels. Again, this is going to import this namespace into all of the views. So if we look back here at contact view model, let it take a second, you'll see it pop up as blue because it now knows what it is, has figured out that that's the model. And where this can help us is by telling the page that this is our view model, is we can use ASP tag helpers to simplify some of this. So instead of saying name, we can actually say ASP4 is the name of the object. And here, as we start typing, it's going to give us IntelliSense into what that view model is. So in this case, I'm going to say ASP.NET is 4. But I can also do ASP.NET 4 on the label. Now, why does this matter? This matters because we're setting properties on the label to say, if someone taps that label, we want you to set the focus in the input. I mean, you really should be doing this in every form you have. There's a for property on label that you can marry it to whatever input or text area or checkbox that you're dealing with. And so let's repeat this behavior for each of the labels, inputs, and text areas. And again, you'll see we're getting IntelliSense in all cases. And remember that this is a replacement for name. You're not going to want to include both. So if we run that without debugging for the moment, a couple of interesting things are going to happen. So because we've tied those labels to the names as well, as we click on the label, it'll actually set the focus to the right property. Now on a top-down, it's not that important. When you start to get to other elements like checkboxes and radio buttons, setting that for becomes important. But I always tell people, please set the ASP4 on labels to all of your forms. It's what users expect to work. They don't necessarily need to just be able to click in the box here, but also be able to click on the label itself, especially when you're using mobile devices where touch is inaccurate. Now that we have the basics of model binding working, let's take a look at validation next. So now let's look at how MVC handles validation. Back in Visual Studio, let's go ahead and open up that ViewModel class. And let's tell the ViewModel class that we want to hint about the requirements for certain properties. So I can actually add an attribute called required. And if we resolve the namespace, we can see this is in System Component Model Data Annotations. And that's going to tell the system that, in our case, all 4 properties are required when someone is sending us data. And there are other types of these, like email address. This is going to validate that the email that's being sent to us is a valid email address. We also have other ones like regular expression, if you really want to get fancy with specific types. And in our case for message, I'm going to use max length. This is going to allow us to tell it that, let's say, make it a smaller number, like 250, that we don't want a message more than 250 characters in length. It's actually pretty small, but this way I can show you when it fails. And in the same instance, I might want a min length of 5 for the actual name, just to make sure it's a real name and people aren't just putting an A in there. Sometimes annoying the user is enough work. So how do these work? We talk about how they work in a couple of different ways. Let's start by just going to our app controller. And when it does this model binding, it also affects another property called model state. And I can check to see model state is valid when the call comes in. The idea here is that if the state isn't valid, we're going to go ahead and show if the state is valid, we're going to do something like send the email. Else, we want to show the errors, right? And we're going to send it back to that page in either case, so we'll return the view. So how does this really work? This is a way for when we're bringing in data into the server that we're going to make sure those rules we've put on the view model are actually followed. So let's put a breakpoint here and let's run this. Let's just add some data and let me make a really big message. Now we're going to get the model with all of that data, but if we look at is valid, it'll actually say false. So it's not valid because, in our case, the message is too long. But how do we even know that? If we look at the model state itself, it contains a set of keys and values for any of those errors. So it contains an error count of how many problems it really has, and inside these collections it will actually show us the state of the errors. But showing us the state of the errors isn't as interesting. Let's get rid of this line for a minute, and let's go back to our contact page, and I'm going to add a new div up here. And I'm going to use another tag helper called ASP Validation Summary, and I can tell it to show all. And what this is going to do is when we know that there's a validation problem after we've been to the server, this will show us all those errors. So let's try sending this message again. And this time it's filling it in with that validation error of saying the field message must be a string or array type, because that's what that validation can use for an error message on strings or arrays, and it says how long it can be. And that is something that's actually configured in your view model class. So back in our view model, stop the project for a minute. Let's go ahead and add error message too long. And you can also localize those names using resources. You can specify the resource name and type that you're going to use for the error message, but we're going to just hard code it here in our example for the moment. Let's run this again. If we send that message again, we're just going to get whatever we put in as the error message, which in our case is going to be too long. And there are actually placeholders you can use to specify the field name and the length that makes it too long. You can look into the docs to get into how to customize those. But what we'd really like is a way to figure out and tell the user that there's some validation problems here before they even click send message. To try to shorten that time, if we just simply wait until they're done with all this, no one's going to be happy. To do that, we're going to come back over to the contact page. And we want to include information about any errors we have. So we're actually going to change the summary to be what's called model only. Model only is going to only show errors that are about the entire view model problem. So if you need two of your fields to match and they don't match, or there's something inherently wrong about missing fields across the entire object, it'll show there. But let's go ahead and add the ability here to just have a quick span that shows us the real error. And here we can say ASP Validation for. So this is going to include the data that we have validation, but for a specific field. So here we'll add the one for name, and I'll copy one for each of the types. I'm just going to put them after the input. We'll add the last one for message. With these in place, we have a way to actually show the errors. If we left everything as is after adding the validation for, that message about the field being too long would actually show up in the span instead of here at the model level. Because there's not a lot of model level errors you're going to show, but they do happen occasionally. The more important ones are the ASP validation for, so you can show the validation next to or around or under the actual inputs that they're trying to type. So we need to have a way to actually include these. So in order to support validation, we're going to use some jQuery libraries that allow us to have some client-side validation based on these same validation elements we have here. What we're going to do first is grab those dependencies, and we're going to do that by adding client-side library, just like we did before. But in this case, we're going to go back to unpackage. We're going to look for jQuery validation. We're going to see it right there. You're going to see some others that have different names, but we want actually jQuery validation, singular, because there are a few different versions. And we're going to do the same thing we did before and only grab what's in that dist folder. And we'll go ahead and install that. And we can see here in our lib folder, we now have that jQuery validation. And we need one more, so we're going to go back to quick add client-side library, switch it back to unpackage. And what we're looking for is jQuery validation unobtrusive. And the idea here is we shouldn't need to include any specific client-side code, that this will kick it off by default. And we'll do the same thing, open the files, we'll see that dist is just those two files, include those, and install those. Now we have the two libraries we need a way to get them on this page. And specifically, since they're plugins to jQuery, they have to come after the jQuery plugin loads. So if we go back to our layout page, because remember, that's where we're loading that jQuery, right? Go down to the bottom. There's our jQuery and our index.js. What we actually want to include here is a section called render section. And what this does is allows you to create a section that can be used on pages that use the layout to inject them on certain parts of the page. And so we're going to call this scripts. And you can either require it, and you might imagine requiring it if you have like a sidebar or a bottom bar or some special section that every page has to include. But we're going to say false here because only the pages that need to inject scripts should include those scripts. And so if we come back here to our contact page, we can then use an @ section, and we'll give it the same name we did before, scripts, and then everything that's put in here will inject itself here on that page, again, after the jQuery is loaded. Then it's just a matter of coming up here and grabbing the files, right? So we want jQuery validate, and we want the unobtrusive after it. And this order actually matters a bit, so make sure that you're getting the validate first and then the unobtrusive. With that in place, let's go ahead and run this so we can see how it works. So we go to this page, we start to type in it. I'll just put like an S there. You'll see we're going to start to get the error that it is required to be at least 5 characters in length. And we didn't go into the server and find that out. It actually happened when we entered anything in the form or made it dirty, and then we pressed tab. Now that we're in here and it's activated it, it's going to show it all the errors. So name is required, and as I type my name, once it reaches the last of the validation, it'll be fine with it. Same with email. If I just leave it at that, it'll say this isn't a valid email address until I put something after it. Subject just needs to be required. So only if I type in it and delete will it show required. And then as we type this, if I haven't done it wrong, probably still not long enough. There it is. As soon as we type and hit that too long length, we'll see the error, whatever the error we made there. We probably will want to write some JavaScript later to make this a little better than having to delete until it goes away. But in that case, it does work. So this is validating it before we send the message, as well as once we send it, it's also going to validate here to make sure that the model state is valid. Even though the client side checked it, you still have to make sure that it's good on the server side. Otherwise, someone could craft up a request to your server with invalid data and get it snuck in with that invalid data. So that's one of the reasons that it makes sense to build these view models that have the validation that can both generate it in the web page as well as be able to revalidate it when it's sent back to the server. Let's make this contact page work next. So to complete this, let's go ahead and add a service. What we would like to do is implement the sending of the email here, assuming the model state is valid. We don't need to do anything special for showing the errors because our view will do that for us. So let's come in here and just assume that we want to send the mail in some way. And so let's just pretend we have something called a mail service, send mail, and we'll just hard code an email here for now. And let's assume that we want to use the model subject. And then for the body, let's just format something like from model.email, message, model.message. And let's go ahead and add model.name here as well. So we have a very quick way to send a quick email via a service. But we're going to need this service first. So let's leave this code here for a moment. Let's collapse everything. And let's create a new directory called services, because we'll need probably more than one eventually. And in the services, let's go ahead and create a null mail service. This will be a service that we can use while testing so we don't actually have to end up running a bunch of test messages. We'll just write to the console some information about the fact that we want to send an email so we know that everything is working together. And so let's create a method much like the one we modeled. So send message, string to, string subject, and string body. And what we want to do is basically log the message, but not actually send it. But how are we going to actually support logging? The way that logging works from a class's perspective is that we can inject a logger into our class that we can use to then log information, no matter where it's going. It's not going to have knowledge of necessarily where it's going. And by default, our project is going to have logging set up for both console as well as the debug window. So let's create a constructor, CTOR, and then hit tab. And we're going to add to it an I logger and then the name of our class. Now this iLogger is inside Microsoft Extensions logging. And then let's go ahead and create a field for it. And you'll see that it creates a read-only field for logger, and then we're tying it together here in the constructor. So that here in the send message, since this is just a dummy mail service, we can just say logger, log info, since this is a pretty low priority message. And we're just going to say to subject body. In the real implementation for this class, we're probably going to need or want to do more to actually send this email. But because we want a null or dummy one, especially while we're running tests or debugging our projects, this allows us to have that dependency. So how do we turn this into something we can then use? First thing you're going to want to do is extract an interface for the class. And what this will do is it'll take the members of the class, as many of them as you need, in our case it's only one, and it's going to create a iMail service interface for us. And it's going to create it in the same directory, which is fine, but it's going to be just the interface that we implement. In fact, here in the NoMail service class, it goes ahead and attaches the interface here. So this is the interface of what it's going to be to deal with the mail service, and you might have other ways of dealing with this. The reason for an interface is we might need different implementations in different cases. It may be that you're allowed to send direct SMTP messages and you use that to implement this. Or probably the preference would be to use some service like SendGrid or MailChimp or one of those services to send your messages so that you can guarantee that they were sent without having to do all the logistics of managing your own SMTP server. So in order to use this in our app controller, to actually use the mail service in our class, we're going to need to open up the startup.cs. We've added services for some of the other systems that we're using, but this is where we would add them for ourselves as well. So we can just say services add, and then we're going to include the class that we want to use. Now there's three different sort of levels of services. There's singleton. And that's when you want to add a single instance that's reused over and over and over again. This is important for things that have shared state, which for the most part you should avoid, or for things that are expensive to construct. Another level of this is add scoped. And practically what scoped means is that within what they call the request scope, so within a single request, you're going to get the same version of the object every time. This is going to be important when we look at database access later. But for us, because this object is pretty thin, we're going to say add transient. And that's going to say, I'm going to create one of these and pass it in. And if a couple of people need it, I may keep it around, but for the most part, it's going to die after each instance. And what we're going to do is we can specify two classes. Of course, we have our null mail service, right? The one that doesn't really do anything, and that will create one that does something real later. But we don't want to have to inject this actual class, because our app controller doesn't want to know that this is the null version versus the real version. So we're going to give it that mail service interface and say, this is the injected version, the type that we're going to inject in, and this is the concrete class we're going to inject. And later we can actually come in here and add the environment, much like we did here with development and release, where, of course, this would be in non-production, and then we would have a production version. We're not going to go through all that trouble right now, but understand that what we're really saying is, I want this mail service to be injected, and for now, the concrete type is this null mail service, a class that implements that interface for me. Let's go ahead and inject it in the app controller next. We're going to use a constructor again to inject the services we need, and in this case, that is going to be iMail service. Bring in that namespace, and I'll just call it mail service. And like we did before, I'll just create and initialize a field for it to make it nice and quick. Notice it's a member of the class, and then we're tying the one being passed into us so we can save it for our methods. And then let's just change the name of the method because we did it differently. And now we have send message being used. So the trick here isn't just to have a bunch of plumbing to make this work. It's saying that the requirement for app controller is that we need a mail service because at least one of our methods requires sending mail. And then we're asking the dependency injection layer to figure out how to construct one of these. We don't want to put the construction of the mail service in every class. We want to centralize it. And so what we're effectively saying is, because in the startup, We've told it that this is the implementation of this. We're asking the service layer to figure out how to construct one of these. And how does it know how to construct one of these? It could just say new mail service. But if you remember, it could just say new null mail service. But if you remember, this implementation has other requirements. So it's going to look at the null mail service that it needs to construct and say, oh, this needs an iLogger as well. I know how to construct one of those. I'm going to create that. Then I'll pass it into the null mail service. Then I'll take that null mail service and eventually send it to our app controller. Our app controller never has to understand that tree of dependencies that are going to be required to get the mail service. This registration in startup.cs is going to do all of the heavy lifting for us. So let's go back to our app controller. And let's do a couple of other things, because once we've sent the mail, we're going to want to show on the page that we sent the mail. So we're going to use that view bag again, though there are other ways to do this. And I'm just going to say mail sent. And so back in the view, to make this work, we then need to just add a little div here and show viewbag.user message. So we're going to take that user message, which normally would be empty. So this would just be an empty div. But when we have a user message, we can go ahead and show it here. So let's see this work beginning to end. Back on our page, I'm just going to refresh. We start with a blank form, and as we start to type, we're going to get that validation that we need from ones that it remembers. Hello, Sean. And then, hi there, right? Very simple contact message. I press send and tells the user down here that the mail was sent. And I want to also clear the form, so I can just say model state.clear. This will clear all the model state so that when the view is shown, all of the fields will be emptied. Again, we only want to clear the fields if we've actually sent the message. So let's build this. And if we go back to an empty contact page, let's show it working completely beginning to end. And when I send message, it clears the form for us and tells the user down here that the mail was sent. Back in our Visual Studio, I can actually go to the ASP.NET Core web server to see what happened during the process. And one of the things we'll see here are a bunch of infos for logging that was shown in this console for the web server. And if we look here, we'll see Dutch treat web service, and then our message, which is this was the email message that we wanted to send, even though it's a null mail service. So that logging we did was spit out here into the console, or in the case of debugging, you'd have seen this in the debug window. Later on, we'll add some more logging so you can see how that works. But let's wrap up this module now that you've seen the basics of MVC. We're going to be building a lot more MVC as we go along, but we're going to do it to implement the rest of our project. So this was just really the introduction. So what have we learned in this module? I've shown you can separate the logic and the controllers as well as the views so you can enable better testing later. I've introduced the layout that allows you to simplify the sharing of the look and feel of a project so that you can have the same sort of Chrome around your website for all your pages. Lastly, we introduced model binding and validation to show you can simplify straightforward forms when you need to without you having to go through and create a SPA just for a single form. Up next, we're going to bring in Bootstrap to further make our website look better.